All right, in this homework, we're trying to figure out what is f prime and f double prime in a lot of these. Let's do this first one together. We're trying to figure out which one is f and which one is f prime. And so the first thing I look at is I know that f prime is the derivative of f. It tells us the slopes of f. And I find the easiest place to look for that is when the slope is 0. So if we look at this parabola, the slope is 0 right here. And if this were f, then this f prime would have a 0, right? The value of f prime would be 0 because the slope is 0, but it's not. So this is going to end up being f prime, and let's see how that looks when we look at this one as f. Since this one is f, the slope is 0 right here, and we can see that in f prime, the value of the derivative is 0. The slope of the tangent line is 0. Right here, where the slope of f is 0, the slope of the tangent line is 0, the value of the derivative is 0. Also, that's like an easy trick to at least like help you narrow things down. There are some harder ones, like the next problem, where you might need to look for things like, well, if this is f, the slope is positive, so the derivative should be some positive value, right? Here, the slope is negative, so the derivative should be some negative value. The slope is positive, so the derivative is a positive value. And so that's another thing to look at to make your determination. Anyway, in this one, f is this guy, f prime is this guy. Another way you could have looked at it is that this is a cubic. This is something x to the third. The derivative of x to the third is something x squared. So you can tell that this parabola is the derivative of this, this cubic function. Okay. Let's see. Let's go to the back and do a few of these asymptoty ones. This is from pre-calculus, and we'll just remember a couple of rules. We'll analyze this function. P of x is f of x over g of x, so I'm going to write over here. P of x is f of x, which is x minus 3 squared over g of x, which is x squared minus 4. And we want to decide how many zeros it has, how many vertical asymptotes, how many horizontal asymptotes it has. And in pre-calculus, you also did holes. So this is something we should already know. Let's remember the rules. If you have h of x equals f of x over g of x, the zeros are where f of x equals 0. Where f of x equals 0, but g of x does not. If they're both equal to 0, it will be a whole. But if only the numerator is 0, 0 divided by anything is 0. G of x, where that one is 0, that's where the vertical asymptotes will be. If you divide by 0, that will be a vertical asymptote unless f of x is also 0 there. So if only the denominator is 0, then you'll have vertical asymptotes. Horizontal asymptotes come from comparing as x goes to it. It's the limit as x goes to infinity. And as x gets bigger and bigger and bigger, what you do is you compare how fast the numerator and the denominator grow. So for polynomial numerators and denominators, we look at what the degree is. In this case, this is x squared divided by x squared. They're growing at the same rate. And so this one has a horizontal asymptote. And the way you find out where the horizontal asymptote is you divide the coefficient. So we have x squared on the top when we multiply it out, divided by x squared on the bottom, and you get 1 divided by 1. There's a horizontal asymptote at y equals 1. So when we're analyzing this function, let's look at this function right here. How many zeros does it have? Well, when x is 3, that makes the numerator 0, and that's the only value of x that will make the numerator 0. So there's 1 0. For the vertical asymptotes, we need to factor the denominator. It's x plus 2 times x minus 2. And there are 2 vertical asymptotes because there's one at x equals negative 2 and one at x equals 2. And because the 2 degrees are equal to each other, there is one horizontal asymptote. One more thing about the horizontal asymptotes you'll need for some of these other ones is that if you have the degrees are not the same, so something like this, you've got x squared over x to the third. Because the degree of the denominator is bigger, the denominator grows faster as x goes to infinity, and this will have a horizontal asymptote at 0. But if the numerator grows bigger, then as x gets bigger and bigger and bigger, this will just go up and up and up, and there will not be a horizontal asymptote. So that's what you need for this homework. Good luck.